Very good morning, students. Last class we discussed regarding the IUPAC nomenclature of coordination compound. Means how to name. What are all the rules we are going to follow? However, means ligand name. And for that ligand, two types. Neutral ligand and second one, anionic ligand. Everything we come to know. And metal name, how the metal name will change, especially particularly in anionic complex, cationic complex. That one also we know. And certain sort of rules for homoleptic, heteroleptic, neutral complex, cationic complex, anionic complex. And how to write the name for the particular formula. If they will give the formula name, how to write the formula. Everything we discussed in the last session. Now, in this class, we are going to study about isomerism. Isomerism in coordination compound. In coordination compound. What is this isomers? Isomerism. First, before that, isomerism anta artha madkolodukku ಮೊದಲು. What do you mean by isomer? Isomers. See, any compound containing same molecular formula. Molecular formula means, for example, just I am giving example. For example, C2H5OH. One more also, C2H5OH. Just I am giving example. Just assume this is different, this is different. Just assume. I am just giving example in order to understand the concept. See, here this one also. C2H5OH, C2H5OH. They look like same. Same means same molecular formula. For example, here also 2 carbon atom, here also 2 carbon. Here 5 carbon atom, sorry 5 hydrogen, 5 hydrogen. 1 oxygen, 1 oxygen. Hydrogen, hydrogen. Means same molecular formula but different spatial arrangements of atom. Different spatial arrangements of atom means I can rearrange this. I will give one general example. For example, here 3 boxes are there. This one is blue color box and this one is green color box and this one is red color box. Here, how many boxes are there? 3 boxes only. Now, I am going to shuffle this. First red, blue, green. Same boxes. What I did, I just shuffled. Next, one more way. First green, next blue, next red. All the 3 sets of arrangements are same? No. All the 3 sets of arrangements are different. Howdalva? See, here 3 boxes the colors are different ಇದೆ. ನಾನು ಅದನ್ನು arrange ಮಾಡಿರೋ. For every time I am going to change the arrangement. Same thing, isomers means same molecular formula. Same molecular formula. But different spatial arrangements of atom. Different spatial arrangements of atom. Try to understand. Same molecular formula means same 3 boxes. Colors change madilla. Blue, green, red. Same type, same molecular formula. But different spatial arrangement. Space means space, universe. In this place. How it looks. Correct na? That is isomers. The phenomena. Phenomena means the formation, the process. That one we call it as isomerism. ಐಸೋಮರ್ ಆಗೋ ಪ್ರೋಸೆಸ್ಗೆ ಐಸೋಮೆರಿಸಮ್ ಅಂತ ಕರೀತೀವಿ. Isomer means same molecular formula but different spatial arrangements of atom. Isomerism means the process, phenomenon. We call it as isomerism. Too simple. Now, in which case we are going to study this isomerism? In coordination compound. You know how to represent the coordination compound. Means coordination compound ಅಲ್ಲಿ ಯಾವ ತರ isomerism ನ observe ಮಾಡ್ತೀವಿ. We are going to observe two types of isomerism. First one, structural isomerism. Structural isomerism. First one, structural isomerism. And second one, stereoisomerism. Stereoisomerism. See, isomerism, especially in coordination compound, two types of isomerisms are possible. First one, structural isomerism, and second one, stereoisomerism. Especially in this structural isomerism, two types we are going to observe. First one, geometrical isomerism. Geometrical isomerism, and second one, optical isomerism. Structural isomerism, two types, geometrical isomerism and optical isomerism. Optical isomerism. Very simple. Structural isomerism. Structural isomerism. The name itself indicates what is this? Structure means within the complex, within the coordination compound, if the ligand will change their place, that is structural changes. That is structural isomerism. In that, geometrical and optical. Geometrical, once again, two types, cis and trans. Cis and trans. Just observe this. Structural two types. I'm going to deal with very precise example. See, geometrical isomerism, two types. Now, geometrical isomerism, see, central metal atom is platinum. What is this? CMI. Central metal atom is platinum here. Around platinum, two types of ligands are there. One is chloride and second one amine. Around platinum. Platinum is nothing but CMI. CMI means central metal ion. Around platinum, two types of ligands. If more than one type of ligand is present, means what type of complex that is? That is heteroleptic complex. Heteroleptic complex. This is heteroleptic complex. One thing you just observe, if all means here two types of ligands are there. What is the coordination number? Coordination number is 4. What do you mean by coordination number? Around platinum, how many ligands are there? 4. See, 1, 2, 3, 4. But all the 4 ligands are same? No. 2 ligands are chloride and 2 ligands are ammonia group. It's a example for heteroleptic complex. Heteroleptic means more than one type of ligand. Geometrical isomerism we always observe in heteroleptic complex but not in homoleptic complex. Why? See, platinum Cl, 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 Cl. In all the cases, only chlorine is there, chloride is there. Now, I am going to change this chlorine by here. Anything difference? Any difference you will observe here? Nothing, no difference, nothing. Why means all the chlorines are same, identical. I am going to shift this chloride from here to here means no always observed in heteroleptic complex. Heteroleptic complex alle observe madu. And then see here NH3, NH3. Two groups are adjacent to each other. Adjacent means what? Nearby. See, two groups are adjacent to each other. Adjacent to each other. See, chlorine, chlorine. Any two groups, they are adjacent to each other. Such type of groups, such type of isomer, we call it as cis geometrical isomer. Adinenadu karithivi cis geometrical isomer. Cis geometrical isomer. Now, what about the trans? Cis ಬಗ್ಗೆ ಗೊತ್ತಾಯ್ತು. Cis means any two group, they should be adjacent to each other. ಯಾವುದಾದ್ರೂ ಆಗಿರಲಿ. Any two groups. You are not supposed to ask, man, here chlorine is there, here ammonia is there. Both are different, but they are adjacent. ಆತರ ಅಲ್ಲ. Any two group, just observe. All the three dimensional ನೋಡಿ ಯಾವುದಾದ್ರೂ two group adjacent ಇದೆಯಾ? If it is present, they are cis form. Suppose platinum Cl NH3 NH3. Any two similar group opposite to each other. Any two similar group opposite to each other. Opposite to each other means NH3 NH3. Means different groups. NH3 Cl, different group. They are not adjacent. See, same group opposite ಆಗಿದ್ರೆ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? Trans ಅಂತ ಕರಿತೀವಿ. What is the name for that? Trans geometrical isomer. See, ಇದು ಎರಡು geometrical isomer, but this one is cis and this one is trans. Why this is cis? Two groups are adjacent to each other, similar groups. But two similar groups are opposite. Not only ammonia, chlorine, chloride. They are opposite to each other. Next example. One example like coordination number 4. Now coordination number 6. Coordination number 6 means around cobalt 6 ligand. It may be same ligand or it may be different ligand. But here I am going to deal with only different ligand. Why? It's a heteroleptic. So NH3 NH3 NH3. Very simple. Here Y plus because it's a cationic complex. If you miss this, the answer is wrong. So it's a cationic complex. Then what type of geometrical isomer this is? This is, see, NH3 NH3. They are adjacent to each other. Yes. NH3 NH3 adjacent. NH3 NH3 adjacent. Cl Cl adjacent. Just assume here four ligands are NH3. Nan beda adu. Tumma differ agiradu yavadu? Kadime iradu yavadu? Cl. Here two Cls are adjacent. Adjacent means they are very nearer. See, after this one only. Then what type of geometrical isomer this is? This is cis. Adjacent idre navu enanta karithivi? Cis. How to write for trans? CO 6 coordination number Cl Cl. Remaining 4 NH3 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 NH3. You can ask, ma'am, here also NH3 NH3 they are adjacent, But here majority 4 ammonia, no? But least one is chloride. Chloride, see, both the groups are opposite. If once both the groups are opposite, it's nothing but trans. Not only in this way, it may like this. Illi chlorine bekaru irbodu. Any group, they may be opposite, or else they are not at all adjacent. Such type of isomer we call it as transform. Geometrical, two forms. One is cis and another one is trans. Cis means both the groups should be adjacent to each other. Trans means both the groups should be opposite to each other. And next one more very interesting example. See, here I am going to introduce an abbreviation EN. What is this EN? EN means last class only I explained ethylene diamine. Here, why should I write like this? EN. See, EN is CH2, CH2, NH2, NH2. Here, which one is a ligating atom? Ligating atom means which atom contain lone pair of electron? Nitrogen. This is one compound. This is one molecule. One molecule ಎಷ್ಟು ligating atom ಇದೆ? 2. Nitrogen. Got it? Means this ligand comes under bidentate ligand. Monodentate, bidentate, polydentate, ambidentate ligand. I explained so many types. Here this ligand comes under bidentate ligand. Bidentate ligand ಅಂದ್ರೆ ಏನು? ಒಂದೇ ligand ಅಲ್ಲಿ ಒಂದೇ molecule ಅಲ್ಲಿ 2 ligating atoms ಇದೆ. 2 ligating atoms means 2 atoms are ready to donate the pair of electron towards metal. See here. Idana shall I write like this? CO, Cl, Cl, NH2, CH2, CH2, NH2. Shall I write like this? En. CH2, 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 NH2, NH2, NH2. Correct now? Here, instead of this, tumba confuse agadana avoid madbekanta, what we did means just simply En anta represent madidini. Just try to understand. This En and this En are adjacent. Or else this Cl, Cl are adjacent. Then this is cis form. What about the trans form? CO, Cl, Cl. En, En. This is trans form. See, both are opposite. Cl are opposite. Trans form. It's a bidentate ligand. Ethylene diamine is a bidentate. That's why, see, it donates 2 pair of electron towards the CO. Only one ethylene diamine donate 2 pairs of electron. That's why it's an example for bidentate ligand. This is regarding cis and trans form of geometrical isomerism. See, this one is there, no? This one is very, very important for 2 marks. In examination, how they will ask the question? Na? They will give the formula for this compound. How to write this? Square bracket. CO. CO means central metal atom. And NH3 3 times. N4 2 3 times. See? CO, cobalt, NH3 3 times, NO2 3 times. Means, it's very simple. they will give this formula and they will ask you to write the isomer for this compound. Here one more special name we are using. First one is facial isomer and second one meridional isomer. See, this is facial isomer. Facial isomer. Isomer. For this, they will give they will give this example only, and they ask you to write the isomer for this type of compound. Try to understand. See, it looks like triangle. See, all the three are NO2, 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 nitro group only. Means all the three nitro groups are present in one side. Such type of isomer we call it as facial isomer. Next, how to write for meridional isomer? CO NH3. See, now the triangle will shift it like this. NO2, NO2, NO2. NH3, NH3. Means all the nitro groups, NO2 groups are present in one side, means such type of form we call it as a facial isomer. Here, if like this, NO2, NO2 same side, but in middle NH3 is there. Such type of isomer we call it as meridional isomer. Meridional isomer. For this, in examination they will give 2 marks. Important compulsory question. Means in so many previous year they ask this type of questions. Write down the facial and meridional isomer for this type of compound. They will give the formula, you should write this. Important for exam point of view. This is regarding geometrical isomerism. Then after the geometrical isomerism, what about the optical isomerism? Optical isomerism. What is this? Optical isomerism means, you know the definition for isomerism. Molecule, the process of forming the same molecular formula but different spatial arrangement. We call it as isomerism, the phenomenon, the process. But what about the optical? The name itself indicates optics. In physics, this word is very familiar to you. What is this? Optic. Optic means light. Means what happens means, first just I explain the theory. After that I will take particular example. Now I am going to take sample. Sample means any complex. Any complex. You can take here. For that, here I am using light source and I am using the filter. Why should I use the filter? Light means, you know, in multiple direction it will move. It will move in a straight line, no doubt in that. But multiple direction it will move. But once it passes through the filter, it will cut off the all unwanted wavelength. And then it will move towards straight and it reaches the sample. Once light enter inside the sample, very simple. Once again I am going to explain. Now I am going to take one light source. Light means, you know, it will always travel in multiple direction. Straight line, no doubt, but multiple direction. I don't want all those things. So I am going to cut all the unwanted wavelength. So I am using filter. Once the light passes through the filter, it becomes monochromatic or a single wavelength. The single wavelength is passed in a straight line towards the sample. Once it enters inside the sample, what happens? Either this sample, it may rotate the light towards the right or towards the left. I don't know that. It depends upon the particular sample. If it rotates towards the right, if the light rotates towards the right, light always travel in straight line alla. Right ge bend ಆದರೆ, bending of light, you know, that is also one of the property of light. If it is bent towards right, we call it as dextro. ಅದನ್ನ ಏನಂತ ಕರಿತೀವಿ? Dextro ಅಂತ ಕರಿತೀವಿ. If the same light it pass towards, it's bent towards or else rotate towards left, we call it as levo. Levo rotatory. ಏನಂತ ಕರಿತೀವಿ? Levo rotatory. Levo rotatory and dextro rotatory. See, now simple. Now I am going to take one source. From that I pass the monochromatic light towards the sample. Once it enters the sample, it may turn towards right or it may turn towards left. Suppose if it turns the light towards its right side, we call it as dextrorotatory. Left side, we call it as levorotatory. Very simple. After that, optical isomerism. You know, I will take one mirror. C-O-E-N-E-N. See, try to understand. This is one particular example. Central metal atom is cobalt. The surrounding ligands all are same, homoleptic complex. Homoleptic. And one more thing, optical isomerism is very common in coordination number 6. It's very common in coordination number 6. Means coordination number 4 idre adu optical isomerism na torsalla. Coordination number 4 and coordination number 6 is very good for geometrical isomerism, especially cis and trans, but not optical isomerism. Optical isomerism is only favored for coordination number 6. Here, for example, this is dextro. How I come to know it's a dextrorotatory? Dextrorotatory means through experiment, like this experiment. Once if I conduct the experiment, I come to know this one is dextrorotatory. Then what about the levorotatory? Levorotatory, dextro andrenu right ಗೆ turn ಮಾಡಿದ್ರೆ dextro. ಅದರ opposite ಯಾವುದು? Left ಗೆ turn ಮಾಡೋದು. Opposite ನ ನಾನು ಯಾವ ತರ ಬರೆಯೋದು? I am going to place one mirror. For example, see, just assume one mirror is there. You are going to put your hand like this. In mirror also you will get the image like this. Correct na? I will take this mirror image. ನಾನು ಏನು ಮಾಡ್ತೀನಿ, ಒಂದು ಫೋಟೋ ತಗೊಂಡು just assume in front of me one mirror is there. ಒಂದು ಮಿರರ್ ಇದೆ. ಒಂದು ಮಿರರ್ ಅಲ್ಲಿ ನಂದು ನಮ್ಮ ಪಾಮ್ದು ಏನು ಬರ್ತಾ ಇದೆ, ಮಿರರ್ ಇಮೇಜ್ ಬರ್ತಾ ಇದೆ. ಮಿರರ್ ಇಮೇಜ್ ಯಾವ ತರ ಇರುತ್ತೆ? ಈ ತರ. ಜಸ್ಟ್ ಅಸ್ಯೂಮ್ ಮಿರರ್ ಇದೆ, ಮಿರರ್ ಇಮೇಜ್ ಬರ್ತಾ ಇದೆ. ಈ ತರ ಮಿರರ್ ಇಮೇಜ್ ಇರುತ್ತೆ. Now what I will do means, ಈ ಮಿರರ್ ಇಮೇಜ್ ನ ಫೋಟೋ ತಗೋತೀನಿ. ಫೋಟೋ ತಗೊಂಡ್ರೆ ಹೆಂಗಿರುತ್ತೆ ಮಿರರ್ ಇಮೇಜ್? ಲೈಕ್ ದಿಸ್ ಓನ್ಲಿ. ಈ ಮಿರರ್ ಇಮೇಜ್ ನ ಒರಿಜಿನಲ್ ಇಮೇಜ್ ಮೇಲೆ ಸೂಪರ್ ಇಂಪೋಸ್ ಮಾಡ್ತೀನಿ. ಸೂಪರ್ ಇಂಪೋಸ್ ಮಾಡಿದಾಗ ಇದು ಬೋತ್ ಆರ್ ಮರ್ಜಿಂಗ್? ನೋ. Try to understand. It's a mirror. I am going to take the mirror image of my right hand. Right hand to mirror image ತಗೋತೀನಿ. Right hand to mirror image ಏನು? ಇದು. It's my mirror image of right hand. I am taking the right hand mirror image, and after that image I am going to superimpose. Superimpose ಅಂದ್ರೆ ಈ mirror image ನ ನನ್ನ real right hand ಮೇಲೆ ನಾನು ಏನು ಮಾಡ್ತೀನಿ, ಮರ್ಜ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಮರ್ಜ್ ಅಂದ್ರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ತಮ್ ಮೇಲೆ ತಮ್ ಇದೆ, ಓಕೆ ನೋ ಪ್ರಾಬ್ಲಮ್. ಫುಲ್ ಇದೇ ತರ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಮರ್ಜ್ ಆಗಿಲ್ಲ. ಅಂಡರ್ಸ್ಟುಡ್ ವಾಟ್ ಐ ಆಮ್ ಟೆಲ್ಲಿಂಗ್? ಇಫ್ ಇಟ್ ಈಸ್ ಸೂಪರ್ ಇಂಪೋಸ್ ಕಂಪ್ಲೀಟ್ಲಿ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಸೂಪರ್ ಇಂಪೋಸ್ ಆಗಿಲ್ಲ ಅಂತ ಹೇಳಿದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಲೈಕ್ ದಿಸ್, ಇಟ್ಸ್ ಫುಲ್ಲಿ ಮರ್ಜ್ಡ್, ಬಟ್ ನಾಟ್ ಲೈಕ್ ದಿಸ್, but not like this. It's not merging. Once it's not merging, we call it as mirror images are non-superimposable. Mirror images are non-superimposed. This non-superimposed, like this non-superimposed mirror images, I call it as enantiomers. ಇದನ್ನ ಏನಂತ ಕರಿತೀನಿ? enantiomers ಅಂತ ಕರಿತೀನಿ. ಮಿರರ್ ಇಮೇಜ್ಗಳು ಈ ತರ ಸೂಪರ್ ಇಂಪೋಸ್ ಆಗಬಾರ್ದು, ಈ ತರ ಆಗ್ಬಿಡ್ಬೇಕು. ಅದನ್ನ ನಾನು ಏನಂತ ಕರೆಯೋದು? ನಾನ್ enantiomers. Non-superimposable mirror images are called enantiomers. ಈ enantiomers ಅಲ್ಲಿ ಒಂದು enantiomer ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಗೆ ಟರ್ನ್ ಮಾಡಿದ್ರೆ ಅನದರ್ ಒನ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಗೆ ಟರ್ನ್ ಮಾಡುತ್ತೆ. ಯಾವ್ದನ್ನ? ಲೈಟ್ ನ. ಕನ್ಫ್ಯೂಸ್ ಆಗಬೇಡಿ. ಮಿರರ್ ಇಮೇಜ್ ನ ಸೂಪರ್ ಇಂಪೋಸ್, ಈ ತರ ಕಂಪ್ಲೀಟ್ ಸೂಪರ್ ಇಂಪೋಸ್, ಎಕ್ಸಾಕ್ಟ್ ಸೂಪರ್ ಇಂಪೋಸ್ ಆಗ್ಬಿಟ್ರೆ ಅದನ್ನ enantiomers ಅಂತ ಕರೆಯಲ್ಲ. ನಾರ್ಮಲ್ ಇಮೇಜು, ಮಿರರ್ ಇಮೇಜು ಎರಡು ಸೂಪರ್ ಇಂಪೋಸ್ ಆಗಲಿಲ್ಲ, ಈ ತರ ಆಯ್ತು ಅಂತ ಹೇಳಿದ್ರೆ ಅದನ್ನ ನಾವು enantiomers ಅಂತ ಕರಿತೀವಿ. enantiomers ಅಲ್ಲಿ ಒಂದು ಕಂಪಲ್ಸರಿ ರೈಟ್ ಗೆ ಟರ್ನ್ ಆದ್ರೆ ಅನದರ್ ಒನ್ ಅದರ ಆಪೋಸಿಟ್ ಲೆಫ್ಟ್ ಗೆ ಟರ್ನ್ ಆಗೇ ಆಗುತ್ತೆ. See how to write the mirror image for this. Just assume we are standing in front of the mirror, means ನಮ್ಮ ಇಮೇಜ್ ಮಿರರ್ ಅಲ್ಲಿ ಹೆಂಗ್ ಬರುತ್ತೆ, ಸೇಮ್ ಥಿಂಗ್ ಈ ಕಾಂಪೌಂಡ್ ಇಮೇಜ್ ನ ಮಿರರ್ ಅಲ್ಲಿ ಹೆಂಗ್ ಕಾಣಿಸುತ್ತೆ ಅಂತ ಬರೆಯೋದು. CO, just try to understand. See, EN and this word EN. See, just assume here one mirror is there. I just place the mirror. ಮಿರರ್ ಅಲ್ಲಿ ಹೆಂಗ್ ಕಾಣಿಸ್ತಾ ಇದೆ? ಇದು ಇಲ್ಲಿರೋದು ಇಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆ, ಇಲ್ಲಿರೋದು ಇಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆ, ಈ ಕಡೆ ಇರೋದು ಅದರ ಲಾಸ್ಟ್ ಕಾಣಿಸ್ತಾ ಇದೆ. ದಟ್ಸ್ ಇಟ್, ವೆರಿ ಸಿಂಪಲ್. ಅಂಡ್ +3 ಚಾರ್ಜ್. ಡೋಂಟ್ ಆಸ್ಕ್ ಮೀ ಮ್ಯಾಮ್ ಹಿಯರ್ +3 ಇದೆ, ನಾವು ಇಲ್ಲಿ +3 ಬರೀಬೇಕಾ ಅಂತ ಕೇಳಬಾರ್ದು. +3 ಚಾರ್ಜ್ ಇರುತ್ತೆ ಅಂತ ನಿಮಗೆ ಗೊತ್ತಿರಬೇಕಷ್ಟೇ. ಅಂಡ್ ಹಿಯರ್ ದಿಸ್ ಒನ್ ಇಸ್ ಡೆಕ್ಸ್ಟ್ರೋ. ಡೆಕ್ಸ್ಟ್ರೋ ಮೀನ್ಸ್ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್ ಗೆ ಟರ್ನ್ ಮಾಡಿದ್ರೆ ಕಂಪಲ್ಸರಿ ಅದರ ಮಿರರ್ ಇಮೇಜ್ ಯಾವ ಕಡೆ ಟರ್ನ್ ಮಾಡಬೇಕು? ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್. This is regarding optical isomerism. Next example for this optical isomerism only. See, once again I am going to place the mirror. Just try to understand. This is homoleptic complex. Homoleptic complex means all the ligands are same type of ligands. But this is not homoleptic complex. This is heteroleptic complex. This is heteroleptic complex. This one is heteroleptic complex. Platinum is there. Around platinum, 2 chloride ions and 2 ethylene diamides. Coordination number 6. I already told you, especially optical isomerism is very common in coordination number 6 but not in 4. In 4 we can't observe this. And see here mirror. This is mirror. What I am going to do this? I am going to take the print. Print means mirror image. Because this one is dextro. I don't know, but through experiments only we come to know this one is dextro. Simply if I see the example, I can't say this is dextro, this is levo. Through experiment only we can say yes, this is dextro, this is levo. How? Based on the rotation of the light towards right, dextro, towards left, levo. Here, see, always right opposite left. Mirror image always opposite to the original image. The enantiomers. And see, Cl. See, this Cl as it is. This Cl is there now, mirror. So, this side. Then, En means ethylene diamond. This ethylene diamond, this side. And this ethylene diamond, it will come that side. En. So, it carries +2 charge. It's too simple. Now, I am going to summarize this fastly. Coordination compound, especially isomerism, two types of isomerism. First one, structural isomerism, stereoisomerism. Still now I didn't touch the stereoisomerism because stereoisomerism, 4 types are there. Later, after this, I am going to explain that. So, structural isomerism, 2 types. First one, geometrical isomerism. Second one, optical isomerism. Geometrical isomerism, once again, 2 types, cis and trans. What about the cis? 2 similar group present at they are adjacent to each other. Trans means they are opposite to each other. And optical isomerism, optical means light, based on the light, whether they are turning towards right or left. We know the property of the light, it's always passed through straight line. Based on that, dextro and levo. Based on that, 2 types, dextro and levo. This is regarding structural isomerism. Now I am going to explain stereoisomerism. Now we discuss regarding the structural isomerism. Now stereoisomerism. Here 4 types are there. First one, linkage isomerism. The name itself indicates linkage. Linkage means, what is this linkage? See, metallic ligand link ಆಗಿರುತ್ತಲ್ಲ, ligating atom, ಅದರಲ್ಲಿ difference ಆದರೆ we will observe linkage isomerism. How? Especially this type of isomerism, mainly we are going to observe in ambidentate ligand. Ambidentate ligand. What is this ambidentate ligand? Ambidentate ligand means doubtful. For example, SCN. What is this SCN? Thiocyanate. This is thiocyanate. Thiocyanate. See, especially in this carbon, no, it does not contain any lone pair of electron, but sulfur contain lone pair of electron and nitrogen contain lone pair of electron. Thiocyanate is a one molecule, no doubt in that. But within the same molecule, 2 ligating atoms are there. Means, maybe sulfur can donate or nitrogen can donate. But at particular instant, particular compound, it may be sulfur may or else nitrogen may donate. Both, they never donate. Such type of ligand we call it as ambidentate ligand. ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ? Ambidentate ligand ಅಂತ ಕರಿತೀವಿ. ಅಂದ್ರೆ at one particular time ಅಲ್ಲಿ sulfur ಕೊಡಬಹುದು ಅಥವಾ nitrogen. ಎರಡು both are ready to donate, but for that instant only one will donate. For example, 2 brothers are there means one small sister. Both have money. ಇಬ್ಬರತ್ರನೂ ದುಡ್ಡು ಇರುತ್ತೆ. But one time ಗೆ ಒಬ್ಬರು ಮಾತ್ರ ಅಮೌಂಟ್ ಕೊಡ್ತಾರೆ. But we don't know ಯಾವ ಬ್ರದರ್ ಅಮೌಂಟ್ ಕೊಡ್ತಾರೆ ಅಂತ ಗೊತ್ತಿಲ್ಲ. That is ambidentate ligand. Such type, see, in which compound ambidentate ligands are present, then aram se we can observe this linkage isomerism. Just I am going to give one particular example. Cobalt, and it mainly contains 2 types of ligand. One is NH3 5 times and NO2. This is heteroleptic complex. Hetero means different types of ligands are there, no? That's why heteroleptic complex. Here just observe here NO2. NO2 is an NH3 is there, no? Ammonia is not ambidextrant ligand, it's a neutral ligand. But this one is a ambidextrant ligand. Ambidextrant ligand. Why we call it as ambidextrant ligand means here nitrogen and oxygen both contain lone pair of electron. For this particular compound, maybe nitrogen they may donate electron, or else oxygen they may donate the pair of electron towards cobalt. We don't know. Suppose if it is red color complex, I am getting red color, then it indicates oxygen donate the lone pair of electron towards cobalt. Means this is nitrito. Nitrito means which atom donate the lone pair of electron towards metal atom is oxygen. This is nitrito. Suppose CO NH3 5 times NO2. They will give like this only. But this compound is not red color, it may yellow color. If it is yellow color, then it's understood here nitro group, especially nitrogen donate the lone pair of electron towards the central metal atom. Very simple. Linkage. If oxygen is linked with CO, central metal atom, then this one we call it as red colored complex. Same CO. NH3 5 time, NH3 5 time, NO2, NO2, Cl2, Cl2, same molecular formula, but the linkage is different. Based on the linkage, the color also different. This is red color, this is yellow color. If it is yellow color, it's nothing but nitro. Then the ligand name become nitro. If it is red color, then the ligand name become nitrito. Very simple and too interesting one. Linkage isomerism. Linkage isomerism means which atom is going to link with the central metal atom. Based on that, we are going to observe the isomer. Especially this isomerism we can observe only with the presence of ambidextrant ligand. Next one, this is also type under this stereoisomerism. Second type, coordination isomerism. Coordination isomerism. What is this coordination isomerism? I will write the example first. After that, I will explain. See, CO. Here NH3 is there. I am not going to write NH3. Instead of that, Cn. 6 times Cr. Instead of Cl, I am going to write NH3. See the beauty of this compound. Coordination isomerism. How it looks? CO, around CO, 6 ammonia groups are surrounded. NH3, 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 NH3. Karna, this is one complex. And second one, Cr, central metal atom. This one is only cobalt, but this one is chromium. Chromium. Cn, 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 Cn. See the beauty here. See, around chromium, Cns are surrounded. Means cyanido groups are surrounded. Around cobalt, amine groups are surrounding. But same. And its isomer. Idra isomerally, see, cobalt, around cobalt, Cn. Around chromium, ammonia group. It's very simple. Means here also 6 ammonia, here also 6 ammonia. But here along with cobalt, but here along with chromium. The exchange of coordinating ligands. Such type of isomers we call it as coordination isomerism. ಇಲ್ಲಿ ligands exchange ಆಗ್ತಾ ಇದೆ metal ಜೊತೆ. Such type of ligand we call it as coordination isomerism. Third one, ionization isomerism. What is this ionization isomerism? Ionize means splitting. Once if we split, we will see the difference. How? I'm going to split this first. See? CO NH3 5 times SO4 Br. This one is carrying positive charge, this one carrying negative charge. Correct na? This is one isomer. What about the other isomer? CO NH3 5 times Br SO4. Just see this. Here, how many COs are there? Only one. Cobalt. How many NH3 groups are there? 5. They are outside the coordination sphere, but in this, inside the coordination sphere. Here SO4 inside it first, outside agide. Now I am going to split this. How to split madadu? CO NH3 5 times Br SO4 plus minus. But one thing you should know, sulfate always carrying -2 charge. But this one is -2 means adha match madbekadre idu +1 andre agutta agalla. This should be +2. How simple. Here +1 -1 charge, but here +2 -2 charge. See the difference. Here +2 -2. You just calculate the oxidation state of metal X. I don't know X. This one is neutral, so 0 plus 0 into 5 0. Br -1. Why? Halogen. So overall charge +2. What happened? X -1 will come this side, means 2 plus 1 3 plus 3. Oxidation state is +3 for this. You just calculate for this. X 0 into 5 0. This one is -2. Overall charge +1. Sulfate -2 na, that's why -2. X +2, this +1 -2 goes to right hand side, means it become +2, it become +3. Means in both the case oxidation states are +3 same. That's why isomerism. But only thing, when we ionize, we will get the different thing. If I ionize first compound, simple ion is bromine. If I ionize second one, the simple ion is sulfate, but not bromine. But both are same compound because same molecular formula. This is ionization isomerism. The name alla gottagbidutte ಏನದು ಅಂತ particularly. Last example, last classification, solvate isomerism. Solvate isomerism, or is also call it as hydrate isomerism. What is this hydrate? Hydrate is nothing but water. Hydrate andre it give the clue. Water is there, means the ligand, the compound mainly contain water. I will give this example. Especially, it look like violet color. It look like violet color. Just try to understand. Chromium is surrounded by 6 water molecule and outside Cl3. one isomer. What about the other isomer? It look like violet color. CrH2O 5 times. 5 times means before 6 times. Now 5 times. One chlorine will enter inside, chloride, Cl. And one water will go out. Before Cl3 is there, one chloride will enter inside this, Cl3 become Cl2. Water 6 times is there, one will go out means 5 times water, H2. It look like grey green. Green color kanisate, grey green. Just see the beauty. Here 6 water molecules are there, where within the coordination entity, the color is violet. Once this outside the coordination sphere chloride is there, no? It will come inside, means in order to balance. Balance ಅಂದ್ರೆ ಇಲ್ಲಿ 6 ಇದೆ ಅಂದ್ರೆ ಇಲ್ಲೂ 6 ಇರಬೇಕು. See 5 plus 1 6. In order to balance that, one water molecule will go out. Then the color become changed. Then once again it's never end. Once again this one more Cl will come inside, one more water molecule will go out. One more Cl will come inside, one more water molecule, it may go out. Then what happened? Color difference we can observe. Violet, grey, green, blue. Means what it indicate means isomers we can easily observe, we can easily identify through colors, through their reaction differences. Here stereoisomerism 4 types: linkage, coordination, solvate. These are all example. Hydrated. See, the name itself give the clue what type of isomerism that is. Yes, this is regarding isomerism. Now I am going to summarize the isomerism concept now. It's very simple. First one, isomerism. Isomerism means isomer means same molecular formula but different spatial or structural arrangements of atom. Here 2 types: structural, stereo. Structural isomerism, once again 2 types: geometrical isomerism and optical isomerism. Structural isomerism, especially geometrical isomerism, once again 2 types: cis and trans. If the 2 similar group are adjacent to each other, cis. They are opposite to each other, trans. Optical means if they rotate the light towards the right, we call it as dextro, and towards the left, we call it as levo. And here one more very important one, enantiomer. What is this enantiomer? Enantiomer is very easy. The mirror images are not superimposed. It's superimposed. If the mirror images are like this, they are called as non-superimposed mirror images. Understood? That is enantiomers. And after that, you know, so many examples we discussed. Just practice once. After that, stereoisomer, in that linkage, coordinate and hydrated or else solvate. These are all examples. So many examples we discussed. Just practice once. You have any doubt means just post the questions. Okay. Thank you.